So I know it's tradition to start talks about 5 minutes late because people are still, coming in. But I have a lot of slides to get through today and a demo. I don't know why I put so much content in here. So I'm just sort of going to get started. Hi, my name's Eric. You won't miss much of this talk at the beginning, so if you're still coming in, no worries. Hi, I'm an engineer at CoreOS. A bit about me. I'm one of the speaking styles that totally likes audience involvement. So don't shout at me, but you're welcome to raise your hand. And if anybody has any questions in the middle of this talk, please feel free. All right, so why are you all at a talk about auth this early in the morning? I guess it's not actually this early. So I'm going to make this terrible assumption, because you all are at KubeCon, that you're going to go back to your normal lives and back to your jobs, and you're going to try to deploy Kubernetes clusters. That might be an assumption that's wrong, but that's the assumption that I am going to make today. Okay? So you are all now sysadmins. Fun stuff. So when you are doing that, you're going to have to deal with this problem. Okay? Whether that's just I want to whitelist some nodes, or I want to set up multi-tenant environments for my team, or God forbid, your customers, and you're going to have to deal with this. So that's what I'm going to talk to you about today. A quick overview. First, we're just going to define what the problem is. Then we are going to talk about what users are in Kubernetes, how Kubernetes thinks about users, how that is different from your assumptions, and so on and so forth. Then we're going to talk about authorization, how we use that user information to actually make policy decisions. Specifically, we're going to talk about roles-based access control, which is a new API in Kubernetes that you all should be using. And then, for anybody on SIG Auth with me, you're going to be kind of bored for this, so we're going to shove in a really cool demo at the end. Cool stuff. Okay, all of you have seen this a million times this last couple days. This is what Kubernetes is. Yay, there's some diagrams. Really important part about this, when we are using Kubernetes, basically everything needs to talk to this thing called the API server, right? You create a deployment using kubectl that talks to the API server and shoves a record in etcd. A controller is watching the API server, sees that record is created, and then acts upon it and creates a new pods and stuff like that. So does the scheduler, does something similar. The kubelet notices that, blah, blah, blah. So today we are going to talk about how the API server authenticates all of the clients that need to talk to it. Obviously, you can't just have anybody talking to the API server. We want to be able to make sure that only the people we want are talking to us. And then after that, we maybe want to start thinking about, OK, what do I want to let each of these clients do, right? The kubectl might have different permissions than the kubelet or the scheduler or your master controllers. Cool. So there's actually been a couple of cool talks on how a request goes through the API server. And we're going to focus on two parts of that. First, how does it parse the credentials and figure out who the heck is talking to it? And then afterwards, how do we add additional policies on top of the information that we pulled out during that phase? So this is the classic authentication, who is talking to me, authorization, can this person do what they want? And this is sort of going to be the split between this talk. It's going to first talk about authentication, and then we're going to talk about authorization. So users in Kubernetes. I'm going to tell a little white lie and say that Kubernetes doesn't have users. Now, that's not entirely true, but that's really helpful for me when I am thinking about these systems. Whatever your view of what a user is, it is most likely not the same thing that Kubernetes thinks of a user as. Excuse me. Users are just strings. So when you get a request, all a user is additional strings associated with that request. Literally just strings, okay? So you might have the string, like my username might be Eric. It might be eric@coreos.com or something like that. But in the end, that is just a string. Additionally, we might have groups, which are also just strings, right? So while my request is coming in, I might say I am part of the developer group or the Gopher group or so on and so forth. Your API server, though, is pluggable. So how we pull that information out is different for every API server that you will deploy, or maybe different. There are very common ones like X509 client auth. There are less used ones like webhooks and so on and so forth. But the important part is that this is a pluggable part of Kubernetes, right? So when you are deploying something and you want to think about authentication, the authentication side, you have to make a decision when you deploy your API server about what you're going to accept. So the most common one that anyone does is client certs, right? I'm assuming that anybody who has deployed a Kubernetes cluster just uses client certs to talk, have their nodes talk, and your kubectls talk, and so on and so forth, right? So, question?
Can you use more than one plugin?
Yes, you can absolutely use more than one plugin. So the question was, can you use more than one plugin, by the way, in case anybody didn't hear that. Basic structure, right? I am the administrator. I create a CA for Kubernetes. I have a key associated with that. I then spawn off client certs that I hand to developers and put on nodes and so on and so forth, right? So when I do that, I'm going to get something like this, right? So if I pop open one of those certs, I'll go ahead and look at that and do whatever. Now, normally when you are interacting with the API server, all you care about, for the most part, all of your deployments or all of your installations of Kubernetes, all they care about is this a valid cert? That's it. But when you start thinking about authentication in a more fine-grained role and then have to think about authorization, these fields actually matter. So if you can't see this, this is the common name of the client cert that I have given, let's say, a kubelet, right? The common name is kubelet1, and the API server will think of that as the username for any request using this client cert. Added in 1.4, we actually pull group information out of the organizations. So that means I can give client certs to my kubelets that say organization kubelets, they're in the kubelet group, and then I can give client certs to developers that have organization developer, and they're in the developer group. And then I can do stuff later with that. So again, most people only really use the is this a valid cert? But as we start thinking about authorization, we're actually going to use that username and group information later on. There are a bunch of other plugins, some of them more elegant and awesome than others. There's a couple ones involved in bootstrapping. So you can say like a token file. If I show up with this token as a bearer token, I will be authenticated as Eric. I will be in the group developer and gophers. If I show up with the other token file, just like as a bearer token, right? Authentication, bearer, one of those. Anyway, the header, the HTTP header that you all are so familiar with. There's also a webhook mode. So you can actually configure your API server just like you would say, I want to use a client CA. You can also say, hey, I would really like to use a webhook. I would like to configure a webhook so everything that comes in with a authorization bearer token sends it off to another service that determines what the user is for this particular request. Okay? Cool little note. This is what GKE uses. So GKE has very established credentials that it uses, but they obviously don't want to compile how to look up in the Google database who you are. So they just configure a webhook, do whatever. Just say, hey, I'm going to go look up this in some proprietary database to determine who the person talking to me is, right? So if you have one of these hooks, or if you have one of these proprietary databases that Kubernetes doesn't support yet, this might be interesting to you. What do all of these have in common, though? You cannot configure any of them through the API. Okay? You have to, when you deploy your API server, intentionally decide, hey, I'm going to provision this master with this API server with these particular flags and possibly referencing these files on disk. You have to do that. Okay? And importantly, it's completely managed outside of Kubernetes. You cannot interact with normal users through the API. And this is sort of where I'm getting at. Kubernetes doesn't really have users. And then we're going to get to the lie. So Kubernetes does have users. They're called service accounts. Service accounts are basically just bearer tokens managed by Kubernetes. And these are the things that you can use through the API to create users as you want. Okay? So what happens when you create a service account? So I do kubectl create service account, and I give it a name. And what I get out of that is a service account object, right? So this thing has the normal metadata. It has the same name I gave it. And additionally, it has some list of secrets, right? What that list of secrets is these are actually the credentials that the service account owns, right? So if you look at that secret, you'll see the CA cert for the API server, so you can talk to the API server securely. You'll see a namespace. It's base64 encoded because this is a secret, but that's just default. And also, there is this thing called the JSON Web Token, which are cool things. What that is just a JSON payload that is signed by the API server. So when you come back with a service account token, the API server says, yep, I'm into this. OK, let's go. So service accounts are used to actually give all of the pods running in Kubernetes identities. Okay? So when you create a service account, you can then associate it with a pod running in a cluster. Okay? You can say service accounts, give it a name, and what that will do is it will mount the secret into your Kubernetes pod. If you do not give it a name here, it'll just default to the default service account in your namespace. Cool. And by mounting this in, you actually have all the information you need to have a secure conversation with the API server and be authenticated as a particular service account, right? So if you look at the in-cluster implementation, all it's doing when it's initializing its configuration, this is just the Go client that probably all of you use to talk to the cluster, the API server inside your cluster. All it's doing is reading that service account, reading the CA, and then using it later as a bearer token. And that's it. It's not particularly magic, but this is how we give pods identities.
Can you go back one slide?
Yep.
So when you have so when this is stored on a volume, is the secret encrypted on disk also?
Secrets are, I believe, temp FSs, so they're never touch disk. But that's details of secrets more than service accounts. Cool. So, yeah, another question.
So, reference to secrets, I thought once you have a secret, they are visible to all potential users within the cluster anyway, right?
Secrets are a can of worms that I don't have the time to get into right now. Yeah. If you want to talk to me about secrets, which is a very interesting topic, and we are gonna, I'd love to have those conversations, but just not quite right now. Cool. So service accounts in Kubernetes. So again, they have just weird names, and they're just signed bearer tokens. Okay, they are just I have some payload and do whatever. And I actually have one right here. It's really ugly, but there's a site called jwt.io that's really nice for debugging these things. Okay, so this is my service account token. Couldn't you tell? And all this is a header with some information like what the algorithm used to sign it was. There's a payload here, and then there's a signature, right? So this comes in, and the API server verifies that signature and unpacks the payload. The payload itself actually has some cool fields. So it has the issuer is Kubernetes. That's pretty cool. There's a subject, which is the service account name. And actually, basically, my only trick that I know in all of Kubernetes is that your namespace is actually in that service account. So, or the service account token. So all of you who are using the downward API like suckers to figure out what namespace you're in, just parse your service account token, and you'll figure it out instantly. I am also using that trick, so I will be the first one bitten if it breaks in backwards incompatible ways. OK. Yeah, they're automatically mounted into pods. Cool. They give each pod an identity in the cluster. And again, if you want to manage users, I don't know why you would use Kubernetes to manage users, because that sounds awful. You would use service accounts, because they're the only thing that you can talk through the API through and interact with users. Importantly, they can totally be used outside the cluster. And as we have noted, their credentials are stored in secrets. What does this mean? Anyone who can read your service account secrets can act on behalf of your service accounts. So be warned, and don't give your service account tokens the ability to bring down your cluster, because, yeah. Cool. There are some other options we talked about. The token webhook will review OpenID Connect and all of its glory later when I talk about DEX, and there are some static file options. Which brings us to authorization. So you guys are all experts in authentication now. Now we're going to talk about authorization. Authorization uses the namespace and groups that we pulled out of the credentials during the authentication phase and uses them to create a policy, right? So, obviously, if you have a group that is named specific things, you want to enforce policies around that. I helped port it in 1.3 from Red Hat OpenShift. So shout out to OpenShift and the guys behind that. They've been awesome. So yeah, and we're going to talk about, we are going to talk about the specific implementation of authorization, one of the plugins, and you can have multiple authorization plugins too, called Roles-Based Access Control, RBAC. Okay, little high-level view, and then we'll get down into the dirty details. So default for all authorization plugins, not just RBAC, is deny all. Okay, it's a safe assumption, but it also makes setting up authorization a pain in the ass. You just have to go through this. I'm so sorry. As we proceed, we will try to give better guidance for how to set up clusters with authorization, but we want to get RBAC to a good state in order to do that. So they contain a subject, verb, and namespace. So you can say something like, user A can create pods in namespace B. You can also emit the namespace. User A can create pods in any namespace. Or for something like a node, which is not namespace, you can say user B can edit pods, or nodes, and emit the namespace. What you cannot do, so first off, just in case anybody was wondering, you cannot refer to a single object in a namespace. This is being discussed and how to do this, but today you can't. And in this way, you want to think of namespaces as your isolating pieces, right? Namespaces are cheap. I had a great conversation with some of the guys from eBay. They just set up a namespace per user, right? And you just use the namespace, and you don't think about having to do multi-tenancy within a namespace, which is way harder. You cannot refer to arbitrary fields in a resource. This is also something we're thinking about adding, but it's also kind of hard, right? So you can't say something like, this person can create a secret, but not of this type. Or read secrets, but not of this type.
Does that mean that you can't refer to labels in these policies?
Correct. You cannot refer to labels. It's just, it is the top-level resource, and that's it. Or actually, and sub-resources, as there's a note right there. Just, not that that is the greatest and greatest thing, but that's sort of the way it is today. So what you can do is you can refer to sub-resources. So you can say, this person can edit the status of a node, but it can't edit its spec, right? That's incredibly useful when you start thinking about all of the cool things that come with sub-resources. So like pods, I think proxy is one, or pods exec. So when you are setting up these, you also have to whitelist the sub-resources. And that's intentional because some of them can be very dangerous. So the RBAC API group has 4 particular top-level objects, a role binding, a cluster role, and a cluster role binding. We will get into why there is the duplication in a second. So roles versus role bindings. Roles declare the set of powers, right? And bindings then come through and bind particular users in contexts to those powers. So you could have a role like admin, and then you can later bind them to a namespace or something like that. So this is just the example of what a role looks like. So I have a secret reader role. It appropriately can read secrets, right? So you see that I've whitelisted all of the verbs that you're allowed to do. You can also use a star if you want to say, I want to give all the verbs to this particular resource. You have to specify the resource, in this case secrets, and you have to specify the API group, or groups that they're a part of. In this case, because v1 is weird and special, it's the empty string. OK, I have my role in my cluster, and now I need to bind a user to it, right? So this is a role binding. It's a little more complicated. But all it says is that I have some role ref. In this case, I'm referring to my secret reader. And this is an alpha API group, so I think this might have changed. So you should go look up whatever the current documentation is and not trust me. And then I have the subjects, right? So this is actually where we get to use all of that information we tried so hard to pull out of the authentication request, right? I told you all this stuff about how you should embed usernames in X509 certs and whatever. But this is actually where we use that information, right? So I want to set up, and I want to say that anyone in this particular group has this power. So why the heck do we have 2 of these things, right? why do we have cluster roles and roles? So objects in Kubernetes can either be namespaced or they're not namespaced. There is no object that exists in both, right? You either define a namespace for a particular object. You have something like pods is a namespaced thing. They exist in namespaces. Nodes are cluster level. They're not namespaced. And you're not allowed to have a resource that bleeds between the two. So as a hack, basically, we have two resources. We have a cluster role, which exists for the cluster. It is not namespaced. And we have roles that exist within particular namespaces. Why would you ever want to use one or the other? Well, so a cluster role is very useful because you can manage one set of roles for your entire cluster that are then used within individual namespaces. Whereas roles are actually less common, and they're going to be used within namespaces. So something like I give someone administrative rights in a particular namespace, they can then create roles in that namespace and defer further. Cluster role bindings and role bindings is the same concept. We need a namespaced version of the binding and a non-namespaced version of the binding. And this is where RBAC gets a little hairy, right? So just to walk you through this, cluster role bindings grant a user power throughout the entire cluster, right? They can only refer to a cluster role in that respect. So you can give somebody the power within the entire cluster to be an admin, or be a user, or be a developer, or whatever you choose to name your role. Role bindings, on the other hand, grant users powers within particular namespaces. And this is pretty powerful. So I would like to give coworker A the power to administer a particular namespace. I create a cluster role that is the namespace admin, and then I give that person a role binding within that namespace that allows them to take on that role. They do not have powers to edit that particular thing, but they still have those powers within the namespace. So just as a diagram form, because I love diagrams, what it is far left, we have a cluster role binding with a cluster role. I have a cluster role. I grant someone powers within the entire cluster. I have a cluster role with a role binding. I have a cluster role that is maintained by a central administrator, and then I bind users within namespaces. And then I have a role or a role binding, which is I have actually managed the role, and then within the same namespace are going to grant people the powers. And the important part is where the role sits, right? So where is the role and who can edit it is actually why this type of setup exists. Cool. Biggest gotcha of RBAC. Role-based access control has built-in escalation prevention. So you cannot give someone a role that you do not have the powers that encompass, right? If I don't have the ability to read secrets, I am not allowed to give anyone the power to read secrets. This is actually built into the storage implementation. So when I do kubectl, create this particular role, it doesn't matter how hard I try and how many flags I give to the API or the kubectl to force that particular action, it just will flat out reject it. The current way you get around this for bootstrapping is either two ways. You either can use a special flag to give a user the ability to escape this, or you can use the insecure port on your API server to actually get around this. Because if you're using the insecure port, you got here without authentication. We're just going to let you do whatever you want. OK, 1.6. What's up?
So if you have RBAC set up, is there anything you have to, like a flag you have to flip for allowing you to do that via the insecure port, or is that just
The question was, if you have it set up, do you have to flip a flag to get around this with the insecure port? The answer is no, but that's actually a relatively new feature. I think that's in 1.6, but not in like 1.5 or something like that. So 1.6, unfortunately, partly because I didn't do the work that I need to, the RBAC API group is not going to graduate to beta. It's still in alpha. That also lets us have some opportunities to test out some new things, which is I'm kind of excited about. The biggest highlight in 1.6 is that we now have default roles. What this means is that there are going to be special names that if you mint if you mint certificates for, like systems kubelet or something like that, then the Kubernetes API server will just have these default roles that you can use for bootstrapping. So the API server just has the default role of what a kubelet is and what access it needs, and you just mint a X509 cert for that particular user for your kubelets. Are those default roles published anywhere yet? They are deep down in the API server code. We're still in freeze, so ideally, nobody's running 1.6 yet, I hope. So we still have time to document that. But yeah, right now they're deep down in the API server code. 1.6 or 1.5? 1.5? I'm so lost about what version we are on right now. Yeah, you're absolutely right, 1.5. 1.5. Yeah. Okay. So 1.5. It's been a long week. Yeah, default roles are the big thing. What's up?
Is the default role is a mechanism you can use in place of the current flag to the API server giving a name for a super user?
The question was, is this a replacement for the super user thing? And yeah, the super user thing is super hairy. Bootstrapping an API server dynamically is hard, right? I want to be able to just say my API server comes up with the set of roles that it needs, and if you have to kubectl create objects somewhere in between that, it just complicates the deployment strategy, right? So these are really big in terms of saying, these are my immutable declaration of what the API server is, and it just comes up with the things that you need, rather than having to have like a bash script that's curling default roles into your API server.
Sorry, follow up for that. So right now with the flag, after you're done bootstrapping, you can remove the flag, and that removes the super userness from the person who's bootstrapped.
The question is,
In this case, would you then remove this default role after you bootstrapped, or is it permanent?
the question is, would you remove the default role after you bootstrapped? And the answer is no. The default role is not necessarily for, it's so you can statically declare and say something like, this is the kubelet's power. It also allows us to think about giving you suggestions and saying, hey, for Kubernetes 1.5, these are everything that the kubelet needs to access, right? And we know this better than you because we have tests that someone's going to break, right? And if new roles are added, we have to figure out migration strategies, but that's just another can of worms. But the idea is, let us declare the things that you need, and then we can work from there. Cool. There's some other plugins. There's a webhook. You can use it. There's actually, I'm blanking on the name, but one of the guys, I've actually seen a really cool webhook implementation open sourced recently. So if you're in here, you should raise your hand, and I can call you out. But, huh? Mike from Pearson. Yeah. He had a really cool implementation of this using the webhook. There's also an API policy file. This is actually what most people are using today, and this is really useful for bootstrapping, but we sort of see RBAC as the default way that you want to go later on, because again, policy is something that you want to control dynamically at some points. Not saying that there aren't static things, but we would like that eventually. Cool. So now, for anybody who knows all this stuff, this is the slightly less boring part. So I'm going to talk about Dex. So Dex is an open source project that I maintain over at CoreOS. What Dex is, it's this thing called an OpenID Connect server. So it implements a protocol called OpenID Connect, which I'm going to go into. This is one of the authentication protocols supported by Kubernetes. So it is actually our way of hooking into the authentication point in Kubernetes. And the important part about Dex is that it actually does this thing. It federates to other identity providers to actually log you in. And we'll go in what the implications of that are in a second. So, and today I'm here to announce the fact that we've revamped the whole project. and releasing a major version. So actually, this has, I think, 999 stars on GitHub. So anybody who wants to give us that 1,000th, do it. Or look at the project first, and then give us the star. So before we go into all the V2 stuff, I'm going to just try to briefly explain OpenID Connect in 5 minutes. OK, OpenID Connect is just OAuth 2. You all know OAuth 2, or you pretended to know OAuth 2 for jobs. That's great. Me too. So the way that OAuth 2 works and the way that OpenID Connect works is that you have some identity provider, in this case Dex, or for Facebook or Google or GitHub or whatever. What?
1,002 stars.
Can we tweet that? Thank you. Awesome. So OAuth 2, you go to an application. That application redirects you to the identity provider that it wants to log you in with. It has some special URL parameters that it uses to do this. But essentially, you go to an app. You get redirected to the identity provider. That identity provider logs you in. Cool. So this is the same thing with Dex. You go to a client application redirects you to Dex. Dex then logs you in and redirects you back to the app with a little code. The app takes that code, goes to the identity provider. That identity provider returns this thing called an access token, right? So if you want to post on someone's Facebook wall, this is what you do, right? I write an application that does this dance. I exchange the code with Facebook to get an access token that I can use with Facebook to like post on their wall or something like that programmatically. OpenID Connect expands the response of the token with one particular field called an ID token. So this is a token response from OpenID Connect. It should look very similar because it is a JWT, right? It's the same thing that it's the same encoding that the bearer token used. This happens to be a JWT signed by Dex. That JWT is, again, header with some information about like what key was used to sign it. It's a payload and a signature. This is the payload. And this is a well-defined payload except for one claim that I will explain in a bit. So they have the issuer, in this case Dex. They have the subject, which is a unique identifier for that user. And you have very convenient things like email. This is just a standard. It's freaking great. And the problem with those access tokens that you get back from Facebook is that they're all completely opaque. You can't look at the access token and get some information. If you want to authenticate somebody with Facebook, you have to write to their API and figure it out. For OpenID Connect, because this is a standard, you parse the JWT after you verify that it was signed by Dex. You look at it, and you get the email from the user, like that, right? And it's just a standard, so that'll work with any other OpenID Connect provider. Dex adds one particular claim that we like, groups, right? You can, developers. Developer, yeah, okay. No, there we go. I now need to update my slides online. All right, cool. So because it is a standard, I can go ahead and take that token and authenticate with the API server, right? You can actually do this with a few other providers. A notable one is AWS single token STS. I forget what that stands for, and so on and so forth. So I can log into Dex and then be authenticated with the API server, which is kind of cool. And then we go back to Dex logs you in through other things, right? It does not log you in through Dex. Dex has a user database for bootstrapping, but primarily its goal is to log you in through some other provider that it supports. So you can log in through GitHub. You can log in through Google. You can log in through your LDAP server. And Dex will figure out how to log you into the Kubernetes cluster. Dex has some really cool features. It has automatic signing key rotation. There's revocation, just because it's OAuth. Lots of login options. Dex v2 was a complete rewrite of Dex. We tried to make it dramatically simpler to deploy. It is now a single scalable binary, and we reworked the storage layer. An important addition to the storage layer is that we can now store a little bit of our state, like refresh tokens, like nonces to prevent replays, in the Kubernetes API server, right? So I can actually store all of the state for Dex in the Kubernetes API server, and you can run natively on top of Kubernetes. Some might say that's an abuse of third-party resources. They may be right. We probably want to switch over to some other, Kubernetes native storage. We're really interested about the etcd operator work. But for now, this at least gets us to where we need to be. So runs natively in your cluster, can authenticate through backends like Google, GitHub, so on and so forth. Demo time. Cool. I have like 4 minutes to do this demo, so we're going to have a lot of fun. OK, so I have a cluster running. kubectl, clear. Cool, I have a cluster running. This is using the CoreOS bare metal repo. Shout out to Dalton Hubble. And it has some authorization rules that I set up. It also has done the appropriate API server dancery to add flags for OIDC. Cool. So pointing to Dex, there's some example app. This is the client that you must log into. There is a CA file and username, claim, and so on and so forth. Here, just darn it, keep still and get deployments. I have a Dex running. All Dex is some pods running, config maps, with a config map mounted in. That config map is super fancy. It has things like where it runs. I don't know. It also has like connectors. So connectors are the way we log you in through another thing. As you can see, I'm about to log in through GitHub. Cool. So in this case, I've configured it to talk to GitHub, and I actually have configured it to pull the teams from the Kubernetes organization, right? So this is how we populate groups of GitHub. We have other strategies for other identity providers. We're also working on this. Cool. So what do I need to do to actually log in? I need to run a client app. Seems pretty reasonable. I give it the issuer, which is Dex, and then give it a CA. Cool. So the way that you log in to any identity provider, again, is that you log in through an application that redirects you there. Not localhost, localhost 555. Right? In this case, I'm going to give an extra scope of groups. I log in, and I get to Dex. This is Dex. I'm going to choose to log in through GitHub. It's going to go to GitHub, and I've already authenticated, so it didn't prompt me, right? And importantly, this is the JWT that we can use to authenticate with our cluster. This is the fact that I'm part of SIG-Auth and feature maintainers, so we've actually pulled groups out of there. And then I can go ahead. Documents. Sorry, I need to look this up. Token equals that really long bearer token. And I am now authenticated with Kubernetes. You can clap now. Three minutes for questions. You must go up there to ask a question because he has a mic. Yeah, go for it. You can just go up there. Yeah.
So you're on a really great path already doing the OpenID Connect. When you start talking to a lot of enterprise customers, I worked on a different open source project, and you're on a very similar path that we were on, and then you're going to realize that customers are asking for being able to work with multiple LDAPs and Active Directories, being able to do SAML assertions in addition as the other way of doing federated identity. And then multi-factor auth. So have you started thinking about all those things that might be coming down the pipe because they come really quickly from the really demanding customers?
Yeah, absolutely. I mean, we are always trying to add new connectors. You can have multiples of these. So if you want to log in with different LDAP servers, that's already a thing. I mean, ultimately, Dex is a really simple project, right? It's an OIDC server. It's like, a few hundred lines of code, does all the things, and then the biggest work for us is just adding connectors in to actually authenticate you. So yeah, I mean, this is why we built it, actually, is exactly for those particular type of use cases.
Hey, about a month ago, there were some really detailed documents in the Dex repo regarding various connectors, and those are gone now.
Yeah, I'm so sorry. I've been rushing to, so 2 points. I've been rushing to try to get the repo switched over to V2 for this demo. I apologize for doing a little bit of marketing-based developing. Yeah, I mean, we're going to try to add those back in. The new implementations are actually a little bit different, and we're still trying to iron them out. Like, I don't know if that's the way we want to get groups from GitHub, so we don't necessarily want to publish detailed documentation quite yet. It's in beta for right now, or what we're calling beta. So as we get to 2.0, we will add that. It will be mandated to add that documentation before we do that. So again, I apologize.
Okay, and then a second question, since no one else is here.
Yeah.
I noticed that all the example docs regarding authorization show just a single wildcard is working. Can you embed a asterisk in a path for like shell-like globbing or regex-like globbing?
So there are these things called non-resource URLs, which I didn't go into. You can do that for those. You cannot do, to the best of my knowledge, you can't do that for sub-resources.
So you can't do that for namespaces or something like that?
So you can use an asterisk for for namespaces?
Well, potentially if you have like a number of namespaces, let's say you have several production namespaces
Right.
that they all start with prod dash whatever. Can
Yeah.
you do prod dash star and have that work?
So the only way to do that, to refer to multiple namespaces, would actually be have a cluster role binding, because that's the top level thing. That has no concept of a namespace, right? So it only gives total access or no access at all. The way you would have to do that is you would have to create individual ones, and you'd probably write a controller to do that. Yeah, you can do the webhook. Realistically, you could write a third-party resource on a controller, right? So I write a third-party resource that declares where I can do something like that, and then I have a controller that spawns off the appropriate role bindings. Would be another way to do it. Sick. Or do you just want to talk after? Okay, cool. Well, thanks everybody for coming. You're